Alright class, in this lesson we're going to learn how to use synthetic division. And what synthetic division does is it helps us not have to use long division to divide a polynomial by another polynomial. Okay? So to do this process, we need to understand that basically what's happening is we're taking this polynomial right here and we're trying to divide it like this by p plus 1, okay? Which is long division. Or another way of writing it is dividing it by, like this way, p plus 1. Well, we've done problems like this before if we were able to factor this and then cancel stuff out. Well, we're not able to factor this, or we cannot factor all the problems, so we're going to learn a new method. Okay, and that new method is to take, in synthetic division, a problem that's in perfect descending order, which perfect descending order means we go from 3 to 2 to 1 to p to the 0 power. This is perfect descending order. And it's important that it's in perfect descending order, because if something was missing, then we'd have to replace it and fill that gap with a 0. So in this case we don't have to, but we'll see one on the next problem. And what we do is we take our coefficients. So what the coefficients are is all the numbers without the p's. So we just take our numbers down, the 5, the -6, the 3, and the 14. Okay, and we have all our coefficients sitting there. And then we take what we're dividing it by, the p plus 1, take the 1, just the 1, not the p, and change its sign. So we're going to take that right over here and put -1. And you put a little L box corner around it. Okay? And now what you do is you draw a math line with enough space right in here to put numbers and to bring numbers down. So the initial startup is to write your coefficients and then to write this number out in front with the sign changed. Okay? That's all kind of the first step. Now, the first actual thing you need to do is take your first coefficient, the 5, and bring it down. So you just write a 5 down here. And now here's where the math magic, I suppose you'd call it, starts. Because synthetic division is really this weird process that we just have to get used to. So the process is you bring the first number down, and then we take that number and times it by whatever this number over here is. And that's -5. So the answer needs to go right over here. So -5 is going to go right there. Okay, so let me kind of clean that up a little bit. So we put -5 right here. And then what you do with these numbers is you add them. So -6, -5. They were opposites, you'd subtract, but they're the same sign, so we add them and make -11. So whatever the result is, you just put it at the bottom. And then we take this -11 and do exactly what we did with this 5 the last time. We take the -11 and times it by -1. The result is +11. So we put 11 right there. Okay? Then we take the 3 and the 11 and we add them and get 14. Okay? And then to finish, we take the 14 and the same thing we've done with every number so far is times it by the -1 and bring the result over here and put -14. And then finally we add the last two numbers and get 0. Okay? Now at this step what you want to do is box this final answer. Okay? The reason why you want to do that is this is actually important. This is your remainder. Okay, and remainders are important because it tells you a couple things. If there is no remainder, like there is none here, it means that this p plus 1 went into this expression evenly. Okay, if there was a remainder, it would not have gone in evenly. Okay, so now what we need to do is write our actual solution in terms of a polynomial expression. Now, what you want to notice is here, we took all our coefficients and brought them down. Okay? Which means now we have to backfill with these p's, the p variables. Okay, so we do that by starting at the 14. This one will be our last number, just like the 14 up here was our last number. It had a p to the 0, had no variable. This one has a p to the 0. In other words, it doesn't have any variable at all, so I don't even need to write that. The next one will have the first p to a power, so first power. And then you keep adding a power as you go along, so p to the second. If there was more numbers over here, I'd say p to the third, p to the fourth, and so on, but we don't have any more numbers, so I don't do that. Okay? So now my final answer is 5p squared minus 11p plus 14. And that's the result from doing my 5p to the third power minus 6p squared plus 3p plus 14 divided by p plus 1. So that equals this result down here. Okay? So let's try this process again. Now on this particular problem, we do not have it in perfect descending order because we go 3, space, 1, none. Okay? So we have to this time fill it. Well, if there's nothing there, then we fill it with nothing. And the way we do that is we write 3x to the third plus 0x squared, which this is still nothing, minus 2x plus 5. So that's a legal algebra move to just add 0. Okay? So we're just filling the gap. And then we're going to take our x minus 3 and change it to a plus 3 and do our synthetic division. So we're going to plus 3 with our little box, bring down our coefficients, the 3, the 0, the negative 2, and the 5. Okay, so you can see those all coming down. And now we do the same process as last time. We draw our math problem bar, bring down our 3. Then you take the 3, times it by the 3 that's over here. And that should give you 9. Okay? Now again, we add vertically, add these together, we get 9. Take the 9, times it by this 3. Then that should give us 27. Okay? So we put 27 right there. Then we go ahead and add the 27 and negative 2 should give us 25. And then we take our 25, times it by 3, which should give us 75, and put 75 right here. Okay? And that should give you 80. Well, this time we actually do have a remainder. Okay, this is our r. The last number again is always r. So now to write our solution, again these are x's, so this one's going to be x to the 0. In other words, no x here. X to the first power, x to the second power. So my result is 3x squared plus 9x plus 25 and plus my remainder. But I don't just say plus 80. In the same way that if I had done like 3 divided by 2, just a side example, this would have given us 3 divided by 2 with long division. 2 goes into 3 once, and then you subtract and you get 1 left over. We learn with long division, when I have 1 remainder 1, I'm supposed to take this second 1 and divide it by whatever was in front. So I'd put 1 and 1 divided by 2. We're going to do that exact same thing over here and take my 80 and put it over what I was dividing by, which was my x minus 3. So I put my 80 over x minus 3 in my actual answer. Okay, so this is your final result from the initial problem, which was 3x to the third minus 2x plus 5 over x minus 3. So that's your final result there. Okay, so let's take it one more problem. Now notice this one's written a little differently. Okay, so we actually have, it just says divide and it looks like a division problem. Okay, so what we're going to do is still do synthetic division. First of all, we're going to check if we had descending order. 2, 1, none. Okay, and again, be careful not to miss that, because if you do miss it, like the last problem, if you didn't catch it, it would give you a wrong answer. Okay, so we take our coefficients now, 5, 16, 15, take our 2, change the sign so it's negative 2, and we get moving on synthetic division. So bring our 5 down. And then that's going to be 5 times that by negative 2, and that should give you negative 10. Okay, so put negative 10 right here, add, and you get 6. Now we take our 6, times it by negative 2, bring it over here, and that should give us negative 12. And then we add, and we get 3. Okay, so this is my remainder. And the answer then is, this is x to the 0, this is x to the first, so it's 5x plus 6 with a remainder, so I say plus 3 over my x plus 2. Now be careful, don't put your x minus 2, you got to go back to the original problem and say x plus 2. Okay? Now if I was asked the question, like if my initial question was, is x plus 2 a factor? So is it a factor? Well, what you do is you do synthetic division and you come down to the bottom and be like, well no, there's a remainder, so it's not a factor. and I'll be showing some examples like that in the next lesson.